So our next factor which we're going to look at is the catalyst. So what's a catalyst? So a catalyst is a substance that alters the rate of a chemical reaction, and in the process it does not get used up. So that means that a catalyst remains intact after a chemical reaction, and it can be used to catalyze several more reactions. Again, a catalyst normally provides some catalysts normally provide surface area. They provide more surface area on which the particles react on. And in case the catalyst is a solid, then making it powdered or using it in powder form will make it more effective, because we know increasing the surface area of a substance generally will increase the rate of a chemical reaction. Again, catalysts normally they do lower the activation energy. If you still recall, we said in order for the reacting particles to combine, they must gain or acquire some minimum energy, which we said or we call the activation energy. And after they have acquired that energy, that's when they have the effective collisions and they form the products. So catalysts are normally lower the activation energy. Here is an example of two types of reaction. One, the reaction is catalyzed, and the other one has no catalyst. So this is my reaction 1, and it is uncatalyzed. And this is an example of another reaction whereby we have used our catalyst. 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 Yeah. So you can see for the reactants here in our reaction A, they have to go to acquire a higher activation energy. This is the first activation energy, activation 1. Then when using the catalyst, the activation energy has been lowered to almost half. And so this reaction will occur faster because the particles required a less activation energy to form the products. There are very many equations that we've learned about them in which a catalyst has been used. So a good example, so we can have a small table here whereby we have the catalyst, and then we can on the other column we can have the reaction catalyzed. So in Form 3 you learned about the Haber process. And in the Haber process, that is the manufacture of ammonia, you realize that that reaction is catalyzed by iron. You also learned about the manufacture of sulfuric acid, which is the contact process. Whereby that one you used vanadium 5 oxide as the catalyst. There are very many other reactions. So we have nickel. Nickel is also another common catalyst. Nickel is used to catalyze the hydrogenation of fats. We also have aluminum oxide. It's a very common catalyst. It is used to characterize the reaction cracking of hydrocarbons to form alkenes and alkanes. We have very many catalysts. Sulfuric acid, it is a common catalyst in the process, in the esterification, and many more. You can go and research more about them. So that's how a catalyst affects the rate of a reaction. In case you use a catalyst will always lower the activation energy, and so the reaction rate will be more faster. So our next factor which we are going to look at will be pressure. How does pressure affect the rate of a reaction? Pressure. So pressure, in case one of the reactants that is being used in a particular reaction is a gas, then increasing or reducing pressure will have an effect on the rate of that reaction. So what pressure does? Pressure tends to compress. It tends to have the same effect as concentration. So when you compress a gas, it's like you are increasing the concentration of that gas. If you still recall your Form 1 work, the kinetic theory, where you say that the particles in a gas are far apart and they move independently from each other. So when you compress, when you increase pressure, then you are bringing the particles together, and in short, it's like you are increasing the concentration of that gas. So due to the and we say that when the concentration of the reactants increases, then it also increases the rate of the reaction. Next, we're going to look at light. So under light, we need to know that there are some reactions which take place when light energy of a particular wavelength is present. A good example of those reactions, I know you looked at this in the organic chemistry, the hydrogenation of alkanes, either the chlorination, the bromination. Those reaction takes place when we have the UV wavelength. UV wavelength. Now you looked at that, I won't go into details. Then we have the photosynthesis. You've done this in biology, for those of you who take biology. And in order for plants to make their own food, then light, especially sunlight, must be present. And finally, in photography, light is also a factor there. So those are the factors that affect the rate of a reaction, and that marks the end of our lesson. Thank you.